What is a linear program? For a linear program, you need three ingredients, and the first one is to introduce some variables. Typically, these variables represent something, for example, the amount of money that you decide to invest in some asset. You can call your variables in any way you like. For example, you can call them x, y, and z, or you can call them a, b, and c, or you can call them alpha, beta, and gamma. And what you actually see often is that people call their variables x1, x2, x3, and so on. The second ingredient for a linear program is an objective function. This objective represents what you want to maximize or minimize with your variables. For example, it could represent that you want to maximize the total earnings from your investments, or it could represent that you want to minimize the potential loss. Your objective function can be, for example, that you want to minimize x1 plus x2, so you want to minimize the sum of x1 plus x2, or it could be that you want to minimize 2x1 plus 3 times x2, or maybe you want to minimize 2.5 times x1 minus 4 times x2, or maybe you want to maximize something. For example, maybe you want to maximize x1 plus x2, or maybe you want to maximize 3 times x1 plus 4 times x2. Now, can you put any function that you could imagine here for your objective function? No. You're only allowed to use objective functions that look as follows. Let's say you want to minimize some number, where I put the question mark here, times the first variable, x1 in my case, plus some other number that you can choose, marked by this question mark here, times the second variable, x2, plus some other number times x3, and so on. Or you can maximize the same thing. So you can maximize some number times x1 plus some number times x2 times some number plus some number times x3, and so on. Of course, the same applies if your variables are not called x1, x2, x3, but have some other names. For example, you could say you want to minimize 5 times x1 plus 3 times x2 plus minus 9 times x3. So this question mark can also be a negative number. Or you could say you want to maximize minus 5 times x1 plus 10 times x2 minus 3/2 times x3. What you cannot do is something like what you see here in red. So for example, you cannot minimize x1 times x2, because here you multiply two of your variables. This is not allowed. Or also you cannot have a term that says plus x3 squared, because you cannot take a variable and square it. And you cannot also not have something like 2 to x4, variable x4 times the logarithm of the variable x5, because 2 to something is not allowed. It's not of the form as you see above. And also taking the logarithm or some other function of your variables is also not allowed. The third ingredient for a linear program are constraints. Constraints are inequalities or equalities that restrict your variables, that restrict the values that your variables can take. And for example, they can represent that you cannot decide to invest more money than you actually have. A constraint can be, for example, that 3 times x1 plus x2 is less or equal than 5, or that 2 times x1 minus 3 times x2 is greater or equal than 15, or that 8 times x1 plus 3 times x2 equals to 12. Can you put any inequality or equality? No, you can only put a certain type of inequalities or equalities, which look as follows. On the left-hand side, you take some number represented again by this question mark times x1 plus again some number times x2 or times your second variable, however it might be called, plus some other number times x3, and so on. Then you have to put less or equal and then some other number on the right-hand side. Or you have the same thing with greater or equal, or you have the same with equality. So for example, one constraint could be 2 times x1, so this question mark number in front of x1 would be 2 plus 7 times x2 plus 8 times x3, less or equal than 15. What is not allowed is to have the same thing with the strict inequality, like here where I wrote strictly less than 15. This is not allowed in a constraint for a linear program. And similarly, also you cannot use a strict greater inequality in a linear program. Also, this is not allowed. Good. So now we have all the ingredients for a linear program. So now let's see one complete example. In my example, we have two variables, x1 and x2, and our objective is that we want to maximize x1 plus x2, subject to four constraints. One says that 2x1 plus 3x2 is less or equal than 18. The second says that 4x1 plus 3x2 is less or equal than 24. And then I want to have that x1 is greater or equal than 0, and also x2 is greater or equal than 0. Now, one possible solution for this linear program is this one here. You set x1 to 1 and x2 to 2, and then you can check that this satisfies all the constraints. And then our objective, x1 plus x2 equals to 3. What is not a feasible solution is what you see here in red, setting x1 to 11 and x2 to 13. Why? Because, for example, if you look at the first constraint, this first constraint is violated because if x1 is 11 and x2 is 13, then on the left-hand side, you get 2 times 11 plus 3 times 13, so that's 61. And this is not less or equal than 18, as we would require by the constraint, so therefore this is not a feasible solution. However, what is a feasible solution is what you see here in green, setting x1 to 3 and x2 to 4. Then you can check that this satisfies all the constraints. And it turns out that this green solution here, where x1 plus x2 equals to 7, is actually the optimal solution, the best solution that you can find, meaning that's the best combination of setting a value to x1 and a value to x2, such that you satisfy all your constraints. And this is the solution of this kind for which x1 plus x2 is maximized. So now you know what a linear program is.